Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how we are tracing the chemistry of an interstellar visitor. So let's get started. What can a single object from another star system tell us about how planets form across the galaxy? Most of what we know about other planetary systems comes from distant observations, but occasionally something from beyond our solar system passes close enough for us to study directly. And when it does, it carries chemical information with it. The object known as 3I Atlas is one of these rare visitors. It originated outside our solar system and is now passing through it. Unlike planets orbiting distant stars, this object can be observed in much greater detail, not because we can visit it, but because we can analyze the material it releases. As it approaches the sun, it releases gas and dust, forming a glowing coma. And that material contains chemical clues. In some cases, molecules absorb light, and in this case, they produce their own signals. Each molecule, including methanol, produces its own characteristic pattern of emission. By observing these wavelengths using instruments like ALMA, astronomers can detect the presence of specific molecules, not by seeing them directly, but by identifying the signals they produce. In this case, observations revealed unusually high levels of methanol, a complex organic molecule. This is another example of how measurement becomes inference, using a different kind of signal. Astronomers record the spectrum of light coming from the object. They identify distinct emission lines, bright features at specific wavelengths. Then those patterns are compared to laboratory measurements of known molecules. If the patterns match, those molecules must be present. From there, scientists can begin to infer something deeper. Not just what the object is made of, but where it came from and the conditions under which it formed. This particular study found unusually high levels of methanol in an object that formed outside our solar system. Because 3I Atlas originated around another star, this detection reflects chemistry from a completely different environment. That's the key result. What makes this especially interesting is that this object contains more methanol than most comets in our own solar system. This suggests that the chemical conditions in other planetary systems may be very different than our own. And that has broader implications. It tells us that the chemical ingredients for planetary systems and potentially prebiotic chemistry may be widespread across the galaxy. We cannot travel to distant star systems, but occasionally pieces of them come to us. By analyzing the light from these interstellar visitors, we gain direct insight into the chemistry of other worlds, not through direct sampling, but by learning how to interpret the signals they carry. So that concludes our discussion on chemical clues from an interstellar visitor. We'll be back again next week for another new discovery in astronomy. So until then, have a great day, everyone. And I will see you in class.